In this video, I'm going to provide for you 4 definitions of oxidation and 4 definitions of reduction. Oxidation is when an atom, an ion, or a molecule does one of these 4 things. Gains oxygen. For example, here we have iron turning into rust. So in this case, iron is gaining oxygen. So iron is being oxidized. If an atom, ion, or molecule loses hydrogen, so here we have methanol, or wood alcohol. You can see that it has 4 hydrogens, and is turning into this product here, which only has 2 hydrogens. So methanol has lost hydrogen, so methanol has been oxidized. For our third definition, when an atom, ion, or molecule loses electrons. So we know sodium's a metal, and chlorine is a nonmetal. What do metals do with electrons? Well, they lose them. What do nonmetals do with electrons? They gain them. So here we have sodium. It will transfer one of its electrons to chlorine. So now sodium has lost an electron. So sodium has been oxidized. And lastly, if an atom, ion, or molecule increases in oxidation number. Here's our reaction. Now we haven't learned about oxidation numbers yet, but we will. The oxidation number on the left for carbon is 0, for sulfur it's 0, and on the right it's -2 for sulfur and +4 for carbon. So we can see that carbon has gone from 0 to +4. So it has experienced an increase in oxidation number. Consequently, carbon has been oxidized. Now, the reason why I'm providing you with 4 definitions, it seems a little bit like overkill, and maybe it is, but I'm providing you with 4 because when I was a student in biology class, I only learned these 2 definitions, these top 2. And then when I took chemistry, I learned these bottom 2. And I had a difficult time understanding, I guess, how these were the same. I was real conflicted. So we're predominantly going to focus on these definitions down here. I just wanted to expose you to all 4 of them so you can see that depending on maybe what field you're in, biology or chemistry, there may be slightly different definitions. However, these bottom definitions, especially this bottom one here, that includes all the rest of these more or less. So really, let's just kind of focus on these 2 bottom definitions here. Now, for reduction, it's going to be exactly the opposite of oxidation. Because as it turns out, oxidation and reduction always occur together. Let me say that again. Oxidation and reduction always occur together. We can't have one without the other. So reduction is when an atom, ion, or molecule loses oxygen. Here we have potassium chlorate turning into a potassium chloride. It's lost oxygen. When an atom, ion, or molecule gains hydrogen, so here we have carbon monoxide. It's turning in to this. It's gaining hydrogen. So carbon monoxide has been reduced. If an atom, ion, or molecule gains electrons, so here we have chlorine. It's gaining an electron. So in this case, chlorine is getting reduced. And lastly, if an atom, ion, or molecule decreases in oxidation number. So this is our same reaction as before. You can see we have sulfur. It has an oxidation number of 0. And then when we're finished, it has an oxidation number of -2. So we've gone from 0 to -2. That's a decrease in oxidation number. So sulfur has been reduced. Here's one more slide that will help summarize what we've learned. This is probably the most important slide of this video. Leo the lion says grr. Can you figure out what those mean? Well, Leo means lose electrons, oxidation. So anytime an atom, ion, or molecule loses electrons, it will experience oxidation. Grr is gain electrons reduction. Now this seems somewhat confusing to have the word gain and reduction describing the same process, but let's remember what's going on. If we're gaining an electron, that means we're gaining something that's negative, so our oxidation number should be reduced or should go down. So if you give it some thought, this will make sense, but it might require you to actually think it through. So make sure you memorize this in addition to having a solid understanding of it, because this slide will be helpful for you going forward.